we have the capabilities right now to track, intercept, and even respond to something non-human entering our solar system as soon as October?
Well, it will be moving relative to Earth at nearly 100 kilometers per second when it's closest to the sun, simply because it moves in the opposite direction to the motion of the Earth. There is no way for us to send a rocket that will intercept with it from Earth.
Something inexplicable has just entered our solar system, moving at more than 200,000 kilometers per hour. Scientists are in shock because it's not behaving like any comet or asteroid we've ever seen. Its trajectory defies predictions. And the strangest part, it might be generating its own light. Some even whisper it could be alien technology. If that's true, the universe just got a lot stranger than we ever imagined. When astronomers first spotted 3I Atlas on July 1st, 2025, it barely appeared as a faint smudge of light moving against the background of distant stars. At first glance, it seemed like just another comet, not unlike the countless icy travelers that occasionally wander into our planetary neighborhood. But what unfolded over the following weeks quickly shattered that assumption. Atlas, by the way, is not just a random name. It refers to the Asteroid Terrestrial Impact Last Alert System, a network of telescopes set up in Hawaii and Chile, whose mission is to spot potential cosmic threats before they get too close to Earth. Think of it as our planet's early warning eyes in the sky. And yet, Atlas did not just detect a dangerous rock. It may have found something far more extraordinary. The first clue was in its orbit. Astronomers quickly calculated what's called its orbital eccentricity, basically how elongated its path around the sun was compared to a circle. For planets, eccentricities are low. Earth's, for example, is about 0.016, almost circular. For comets, they can be much higher, but still tied to the sun's gravity. But 3I Atlas, its eccentricity wasn't just above 1. It was far beyond, meaning it wasn't orbiting our sun at all. This object was not bound to our solar system. It was a visitor from somewhere else. Let's put that in perspective. Before 3I Atlas, we had only ever confirmed 2 other interstellar objects. One, Oumuamua, famously discovered in 2017, and 2I Borisov, seen in 2019. Each of those discoveries shook astronomy, but those were rare, once-in-a-generation finds. So the mere fact that a third interstellar wanderer has been spotted is already an extraordinary event. It forces us to rethink just how common these cosmic drifters might be. But 3I Atlas is not just interesting because of where it came from. Its speed is equally baffling. This mysterious body is racing into the inner solar system at over 200,000 kilometers per hour. To give you an idea, that's fast enough to travel from Earth to the Moon in just under 2 hours. Such velocity makes it incredibly difficult to track and even harder to explain using standard models of natural celestial mechanics. Initially, many experts classified it as a comet. After all, comets, by definition, are icy leftovers from the formation of star systems, often carrying pristine material billions of years old. But here's the catch. Even for comets, 3I Atlas doesn't fit the pattern. Its coma, the fuzzy halo of gas and dust that usually surrounds a comet when it nears the sun, looked unusual. Early spectroscopic data suggested elements and compounds not typically seen in comets that enter our view. At this point, scientists began asking dangerous questions. Could it be something else entirely? Now, the name itself, 3I Atlas, tells part of the story. The 3I designates it as the third confirmed interstellar object ever recorded, a monumental classification. And being only the third of its kind, each detail about its properties becomes amplified. Where did it come from? What processes shaped it? And most importantly, what secrets does it carry from beyond our stellar nursery? Let's talk about possible origins. Astrophysicists suggest these bodies could be ejected fragments from the early chaotic birth of other planetary systems. During planet formation, giant gravitational interactions can fling chunks of rock and ice out into the void, turning them into eternal galactic nomads. If that's true for Atlas, we may very well be looking at a time capsule, a fragment of an alien star system older than humanity, drifting through interstellar space for possibly millions of years, only to end up here, passing our cosmic doorstep. But before we get romantic about it, let's circle back to the facts. The data up to this point showed something clear and undeniable. It was moving far too fast to be a captured object. Its orbit proved conclusively that it came from outside, and the structure of its halo suggested an odd, possibly exotic mixture of materials. This combination instantly drew comparisons to Oumuamua. Remember, Oumuamua wasn't just bizarre for its cigar-like elongated shape, it also behaved strangely. It accelerated slightly as it left the solar system, as if being pushed by some subtle force. That's what led Harvard astronomer Avi Loeb to controversially suggest that Oumuamua might actually have been a probe, possibly even alien technology. At the time, that theory was dismissed by many, sometimes even mocked in academic circles. But with Atlas emerging, those whispers returned, louder than ever. The deeper scientists looked into 3I Atlas, the more the object seemed determined to defy every box they tried to put it in. One of the biggest shocks came not from its orbit, not from its speed, but from something even more fundamental: the way it shines. Objects in space reflect light. That's Astronomy 101. Planets glow because they reflect the sun's rays. Comets, too, shine when sunlight hits the ice on their surface, making them sparkle with a glowing tail. But Atlas doesn't follow that script. Using the Hubble Space Telescope, astronomers noticed something strange. The intensity of the light coming off Atlas didn't match how big the object should be. Based on its brightness, initial models estimated Atlas could be around 20 kilometers in diameter. Think of something the size of Mount Everest floating through space. But then came a contradiction. If Atlas were really that large, its light curve, the way its brightness changed over time, should have been much flatter, more predictable. Instead, the data showed sharp peaks, sudden shifts, almost like the object was flaring, or possibly glowing on its own. Let me put that into perspective. If Atlas is actually producing its own light rather than just reflecting it, it could mean the object is dramatically smaller than we think, perhaps only a few hundred meters across. That's more like the size of a city block, not a mountain. On a cosmic scale, that's a massive difference. And here's the kicker: if it truly is that small, something about the brightness doesn't add up. One astronomer put it simply: it's like shining a flashlight into the night sky. If it really is that small and still this bright, some kind of energy source must be powering it. But what kind of energy source could make an object appear to glow all on its own, millions of kilometers from the nearest star? That's the exact question that sent ripple after ripple through the scientific community. Some experts argued it could be a form of outgassing, when ice trapped beneath the surface rapidly sublimates, creating jets of gas that reflect extra light. We've seen this happen with many comets before, but once again, Atlas resists easy answers. Spectroscopic analyses from telescopes in both Chile and Hawaii showed inconsistency in the readings. Yes, there were traces of water ice, carbon-based compounds, and silicates, materials we expect in comets, but not in the volumes or behavior that would explain the sharp brightness changes. This is where the debate really took off. some researchers began floating far more radical explanations. Could the object's glow be powered by unknown radioactive decay inside its core? If it contained unstable isotopes, it might release energy that explains the glow. But to shine at the levels we see, Atlas would need an extremely high and extremely unlikely concentration of radioactive material. Others proposed thermal emission, basically heat being radiated out from an unusually warm core. But how would an object traveling for millions of years through freezing interstellar space suddenly build up enough heat? The math just doesn't line up. Then came the idea that made the biggest headlines and turned 3I Atlas into a subject of late-night whispers. Harvard astronomer Avi Loeb, alongside Japanese astrophysicist Eric Kito, suggested that the glow might not be natural at all. Instead, it could be artificial illumination. Yes, artificial. In other words, not something nature put there, but technology. Think of it like this. If a spacecraft were built to travel the galaxy, it might carry some kind of illumination, just as our ships at sea use lights for navigation. Or maybe even, as Loeb controversially suggested with Oumuamua years earlier, the brightness could come from a sail-like structure, capturing starlight as a source of propulsion. But in this case, with Atlas, the glow seems persistent. It doesn't fade the way reflected light should. It almost hums. Of course, suggesting alien technology is the fastest way to divide the scientific world. Many scientists argue that extraordinary claims require extraordinary evidence, and so far, no one can say for certain what's powering this light. But let's pause for a second. Even entertaining the possibility that this glow might not just be random cosmic chemistry pushes us into uncharted territory. Because if it's true, then right now, inside our solar system, we might be watching something built somewhere else. Others caution against jumping straight to aliens. They point to the risk of what's known as the anthropic bias, interpreting phenomena in ways that tie back to our human experience. Just because a strange light looks engineered doesn't mean it is. Nature often finds ways to surprise us. But here's the problem. Even if you strip away the alien speculation, the glow of 3I Atlas still does not fit standard cometary models. And that alone is enough to cause sleepless nights in observatories around the world. Because if our models can't explain this, it means our understanding of interstellar objects, these rare visitors from other star systems, is deeply incomplete. When word spread that 3I Atlas might be producing its own light, the scientific community erupted. For some, it was an exciting puzzle, a chance to refine models and learn more about interstellar objects. For others, it was far more unsettling. Maybe for the third time in less than a decade, we were staring at something nature alone could not explain. This is where names like Avi Loeb entered the spotlight again. Loeb, a Harvard professor and one of the most controversial astronomers of our time, has built his career on daring to ask the question many avoid. What if it isn't natural? Years earlier, when Oumuamua zipped through our solar system, Loeb suggested it might be a light sail probe sent by another civilization. The idea was dismissed as sensationalist. Yet now, with Atlas, some of the same anomalies are back. Unexplained brightness, unexpected trajectory, and statistical rarity that defies probability. Astronomers estimated a large interstellar comet, about 20 kilometers in diameter, should only pass through our solar system once every 10,000 years. So what are the odds that in just 8 years we detect not one, but 3? Either it's a streak of luck, these objects are more common than thought, or some aren't objects at all. Loeb and Japanese astrophysicist Eric Kido suggest Atlas's brightness could be artificial illumination. That phrase alone changes the conversation. If true, it implies an internal energy source, not reflection, not dust, but something closer to technology. Why would anything send a glowing object between star systems? One theory is navigation, a beacon signaling itself across space. Another is communication, a galactic lighthouse guiding travelers. A darker idea is surveillance. Disguised as a comet, it could quietly watch other systems. And that opens larger questions. Who built it? When? At our level of understanding, interstellar journeys take millennia. That means either Atlas has drifted for eons, or its makers command propulsion beyond our imagination. Of course, many scientists reject this. They argue extraordinary claims demand extraordinary evidence. Why jump to aliens when natural processes could explain the glow? Yet those explanations feel increasingly strained. If Atlas is smaller than expected, its glow is still disproportionate. If larger, its motion doesn't match predictions. Either way, the numbers don't sit comfortably in existing models. So what if Atlas is technology? 3 possibilities emerge. 1. A probe, the interstellar equivalent of Voyager, drifting long after its makers are gone. A messenger, not a threat. 2. A surveillance device, not random at all, but deliberately placed to observe the solar system, maybe even Earth. 3. A relic, technological debris from a civilization now extinct, still glowing from a durable power source. None of these ideas sit comfortably with humanity's desire to feel alone and safe. Perhaps that's why so much pushback exists. To admit the possibility is to admit contact might already be happening, quiet, unannounced, hidden as a comet. But history reminds us, every time humanity thought it understood the cosmos, reality forced us to rethink. Once we believed Earth was the center, then that our solar system was unique. Now we must ask, are visitors, natural or technological, brushing past us more often than we dared to imagine? If Atlas is not behaving like a normal interstellar comet, then what on Earth, or beyond Earth, is powering its uncanny glow? By now, astronomers are divided into 2 camps. One favors natural explanations. The other dares to entertain the possibility of something artificial. And that's where the tension begins. The most conservative scientists turn first to radioactivity. It's possible, they say, that radioactive isotopes buried within Atlas are slowly decaying, releasing heat and light over time. After all, Earth itself glows faintly in infrared thanks to natural radioactive processes underground. But here's the flaw. To produce the intense brightness we're seeing, Atlas would need far more radioactive material than any cometary body should reasonably contain. The math pushes this explanation to the edges of credibility. Others suggest internal thermal emission. Could hidden reactions deep inside be keeping it unusually warm? Maybe it's radiating heat built up long ago, like a cosmic thermal battery leaking its energy into space. But this raises another problem. Atlas has been wandering the galaxy for millions, maybe billions of years in near absolute zero conditions. Where would such heat come from, and how has it lasted this long? Again, the numbers don't align. The third option is outgassing. Volatile chemicals under the surface suddenly vaporize when exposed to sunlight, creating jets of gas and dust that brighten the object. This is common in comets. We even saw it firsthand with the Rosetta mission to Comet 67P. But once again, Atlas doesn't quite behave like the comets we know. Yes, telescopes detected water ice, carbon-based minerals, and silicates, but the volume is wrong. The amount of material simply does not explain the enormous flare-like brightness. And here's the strangest twist. The ice found on Atlas is chemically pristine, untouched since its formation, suggesting it has never once passed near a star until now. So why is it glowing so unnaturally here on its first known visit to a solar system? That's when the radical idea resurfaces. What if the illumination is not natural? Avi Loeb and his colleague Eric Kito argue that we should simply accept what the data appears to be telling us. This object could be emitting artificial light. Imagine that for a moment. A probe could use illumination for navigation, communication, or signaling its presence across the void. A spacecraft might shine deliberately to announce its location, just as lighthouses once did on Earth. Or, more disturbingly, what if the glow is part of an observation strategy, a way to remain visible, to lure attention, or even to camouflage a deeper function? Because here's the jaw-dropping fact. To shine at the levels observed, Atlas would require a continuous energy output of nearly 10 gigawatts. For comparison, that's the equivalent of powering 8 million homes. Natural geology struggles to justify anything close to those figures. 10 gigawatts is not a cosmic accident. It's the scale of infrastructure. If the strange glow of Atlas raised alarms, its path through the solar system practically set the scientific community on fire. Because when astronomers mapped its trajectory with precision, they found patterns so unlikely, so statistically improbable, that some began whispering the unthinkable. What if this thing isn't just passing through? What if it's navigating? From the moment of detection, researchers confirmed that Atlas was on a retrograde orbit, meaning it's moving against the usual flow of planets around the Sun. That, in itself, isn't necessarily impossible. Some comets travel retrograde as well. But here's what makes this case different. Its orbital plane is inclined only about 5 degrees from the ecliptic, the same flat disk where all the planets orbit. For an interstellar object that should be flying in randomly from any possible angle in the galaxy, this alignment is almost freakishly precise. The odds? About 0.2%. In other words, almost impossible by chance alone. Imagine tossing a dart across a room with your eyes closed and hitting a target the size of a coin on the floor. That's how unlikely this alignment is. And yet, here it is. But the coincidences didn't stop there. As Atlas approached deeper into the solar system, astronomers noted it would have a series of incredibly close encounters. First with Mars on October 3rd, passing within just 29 million kilometers, a near brush in cosmic terms. Then, on October 29th, it would make its closest pass by the Sun, known as perihelion. And after that, another startling alignment. It will pass within 33 million kilometers of Jupiter, the giant of our solar system. Now, here's where things get suspicious. Each of these encounters lines up in ways that almost look orchestrated. You could argue it's pure cosmic accident, but some trajectories suggested Atlas might be pulled into gravitational slingshots, as if it's deliberately using planetary gravity to adjust its course. This is a maneuver our own spacecraft use all the time. NASA's Voyager probes, for example, gain the speed to leave the solar system by carefully bouncing between the giant planets. Could Atlas be doing the same? And if so, why? Here's the most unsettling twist. The moment of closest approach to the Sun. The moment when the object would be bombarded with the most light, heat, and therefore the best opportunity for observation, occurs precisely when Earth cannot see it directly because of the Sun's overwhelming glare. To some, this is sheer coincidence. To others, it feels like deliberate timing, a tactic to avoid close scrutiny at the very moment it would reveal the most about itself. If Atlas were a natural comet, The alignment of all these events, inclination, close planetary encounters, hidden perihelion, would be considered extraordinary, but not impossible. But if it were artificial, these alignments start to look less like chance and more like planning, perhaps even strategy. Some fringe theorists have gone further, suggesting that Atlas's encounters with Mars and Jupiter might not be accidents at all, but part of a path designed to probe planets, measure magnetic fields, or even test reactions of their atmospheres. To them, the trajectory looks more like a survey mission than a random flyby. Others have even speculated the close pass by Mars could give it an opportunity to scan the red planet for evidence of past or present life. A chilling thought when you realize the same logic would apply to us on Earth. And let's not forget what we've learned from history. Interstellar probes like our own Voyagers were launched in the 1970s with data plaques specifically designed to be found by extraterrestrial intelligences. If we did this with relatively primitive technology, how much more advanced could a civilization millions of years older than us achieve? Could Atlas be one of their Voyagers, casually using orbital alignments to maneuver through star systems? Of course, skeptics demand restraint. They remind us that interstellar objects must obey the same law of gravity as everything else. They argue it's only natural that some trajectories appear to line up with planets, because in a solar system filled with massive bodies, interactions are inevitable. They insist the object's retrograde orbit, even highly inclined, does not mean planning, just the mathematics of chance. They say it's dangerous to assign intent where there is none, because here's the terrifying possibility. If Atlas's path is controlled, that implies control. And if there's control, that means intent. And intent always provokes the hardest question of all. What is its purpose? As the mystery of Atlas deepened, one fact became clear. Scientists were splitting into factions. Most astronomers leaned toward natural explanations, while a smaller vocal group asked whether Atlas's behavior might be artificial evidence of something beyond humanity. Skeptics argue first. To them, Atlas is unusual but not inexplicable. UCLA researchers note its dust production and ejection speeds fall within the range of active comets. Strange, they remind us, does not mean intelligent. They also point to the so-called self-illumination. Maintaining Atlas's brightness would require continuous energy near 10 gigawatts, like 10 nuclear plants running non-stop. Even for an advanced species, sustaining that kind of power across centuries seems improbable. Yet others argue dismissing anomalies is intellectual laziness. Harvard's Avi Loeb stresses that inconvenient data should not be ignored. If the glow cannot be explained by dust, gas, or heat, why rule out artificiality? Extraordinary claims do demand extraordinary evidence, but pretending anomalies don't exist halts progress. Occam's razor divides them. Skeptics insist Atlas is a rare comet. Radicals claim sometimes the simplest explanation is also the boldest, that it is technology. Even skeptics admit discomfort over its lack of gases and its peculiar trajectory. Adding to the tension is stigma. Alien hypotheses still risk reputations. Some scientists suspect this bias keeps the community blind. Would real evidence even survive such scrutiny? What emerges is almost a human drama. Meticulous researchers defending comet models versus colleagues daring to imagine technological origins. One side calls for patience and data, the other for boldness and the courage to face possibilities that could transform history. The mystery of Atlas is only beginning. In October, it swings past Mars, just 29 million kilometers away, close enough for the high-rise camera to potentially capture the first close-up images of an interstellar visitor. Weeks later, on October 29th, it reaches perihelion, its closest pass to the Sun. There, solar heat could trigger comet-like activity, though Earth won't see it directly. Instead, the James Webb Space Telescope will probe its strange glow with unmatched precision. In December, Atlas makes its closest approach to Earth. It's safe, but close enough for observatories worldwide to study in unprecedented detail, alongside the newly operational Rubin Observatory, which may reveal whether more objects like it are out there. What follows could go two ways. Atlas may prove to be a natural comet, carrying primordial materials from another star system, rewriting planetary science. Or, if anomalies persist, too bright, too quiet, too precise, the possibility of something artificial grows harder to dismiss. For the first time, our instruments are powerful enough to give us real answers. The coming months may tell us whether Atlas is simply frozen debris or humanity's first glimpse of interstellar technology. Either way, it forces us to confront a truth. The universe still holds surprises we may not be ready for. So, what comes next isn't just about one comet. It's about whether we finally learn the truth or uncover an even bigger mystery.